Siren systems were first widely used during World War II to warn of possible air attacks. Early on, that wailing effect was generated by forcing air against a perforated disc. Today's siren sounds emanate from higher-tech systems and still mean trouble is on its way. From atop towers and buildings, siren systems warn surrounding communities of impending tornadoes, floods, or any calamity. Today's sirens can broadcast both warning tones and live voice messages. They can also be activated by remote control from anywhere in the world. The messages and warning tones from a typical system can be heard from almost 3/4 of a kilometer away. Production begins with the transformers for the amplifiers. A worker winds thick insulated copper wires around a plastic bobbin to produce the transformer's primary coil. She compresses the wires to eliminate gaps. A tight winding is critical for generating a magnetic field and transferring it to a secondary coil. She wraps insulating tape around the primary coil. She winds thin wire over it to produce the narrower secondary coil, and she encases that in more insulating tape. Next, with swift dexterity, an employee stacks E-shaped iron insulators in the center of the bobbin to build a core. She inserts smaller iron insulators between the E-shaped ones, and this tightens up the pack. She taps them into place and now has a dense iron core that will aid the flow of energy between the transformer coils. With an enamel coating baked on and the assembly wired for sound, this siren transformer is now complete. A computer-operated machine now punch-cuts assembly holes in an aluminum panel that will be used for a section of the siren cabinet. A robot transfers the panel to a computerized bending machine. Another robot feeds the panel to a clamping bar and, using hydraulic might, bends it against the clamp in strategic locations. This transforms it into a section of the siren's back and side walls. It also folds the edges, creating flanges for the cabinet door assembly. This computerized system takes less than a minute to complete all these folds. The robot then transfers the siren cabinet part to a conveyor, and it's on to the next station for assembly. Ahead, some cabinet brackets are in the wash zone. As the parts travel through, they get a soapy spray and then a rinse. After drying, the parts head into a powder paint booth. Sprayers apply dry powder paint to the surface of the parts. It takes 8 automated guns and 2 manually operated ones to evenly coat these brackets. The paint is electrostatically charged to cling to the metal, but at this point can be rubbed off like dust. Baking it causes the particles to melt and bond to the surface for a smooth and very tough paint job. This worker now installs the Siren Systems control board. It regulates the siren's 6 tones, 16 pre-recorded messages, and the public address function. He bolts it to the inside of the cabinet door. Next up is an amplifier equipped with the transformer we saw assembled earlier and the amplifier board. He installs the completed amplifier in the cabinet and connects it to the control board. There are 5 amplifiers in this siren system, one for each speaker on the tower. He equips it with a control pad for on-site activation. Then a 1,500-ton press injects hot liquid plastic into molds. In seconds, the plastic cools and the press retracts to reveal the new speaker parts. They bolt the speaker house together, install the screen through which the siren sound emanates, and top it off with a plastic cap. They install a 400-watt driver in each section of the siren's speakers. The more speakers there are atop the siren tower, the greater the reach. The most powerful can be heard many kilometers away. Emergency vehicles are equipped with smaller versions of these systems to warn motorists of their speedy approach. The concept is basically the same: to get your instant attention.